One of the things that you need to be successful in math is a good understanding of the fundamental concepts. And if you think about one of the most basic ideas in math, it is numbers. And there are some things that we can learn about numbers. They have certain features and certain properties. And I think this activity that I'm about to do is something that is accessible for many different levels. I think everybody can learn something from this. If you already know how to do this, then when you watch this and you see me go through it, and you hear how I emphasize how important it is, then if you already know everything that I'm about to say, then you still benefit from this because it's a verification that your knowledge is at the level that it needs to be. So even you can benefit from listening to this, and for everybody else, if you learn something, of course, that's kind of self-evident that you've benefited from this. So what I'm going to do is this thing called, let's see here, the Sieve of Eratosthenes. I think that's how you say it. I think that's how you spell it. And what we do here is we eliminate certain numbers based on certain features, and then we're left with other things. A sieve is a filter, so we're filtering out certain numbers. So first thing we're going to do is we're going to cross off 1. And then the next thing we're going to do is we're going to cross off we're going to circle 2, and then we're going to cross off every multiple of 2. So cross off 4, cross off 6, cross off 8, cross off 10. And maybe you can see why we had to cross off 1 here. Because if we circled 1 and then we crossed off every multiple of 1, then 1 would have been the only number that we circled. So we can't follow that same procedure with 1 that we're using with 2. If we do it with 2, then we at least have some of the numbers left, but we're crossing out a lot of them. And maybe you can see which category of numbers are being crossed off right now. These are the even numbers. And that's, I believe, something that comes up in 2nd grade, but something that's useful for a very long time through many grade levels. You can start to see here that the tens place doesn't really matter when it comes to determining what an even number is. So you can just cross off all of the numbers that have a 2 in the ones place. Cross off all of the numbers that have a 4 in the ones place, 6, 8, and 0. So we are crossing off numbers that are multiples of other numbers. They are divisible, like 4 is divisible by 2, 6 is divisible by 2. And we're circling numbers that are kind of indivisible, like 2. The only way you could organize 2 dots is like this. I mean, you could rotate it and organize it like this, but that's a huge difference between 4, because 4, you could organize it like this, or you could break it into 2 rows of 2. So 2 looks like this, 4 looks like this, and we can see that there is a difference between a number like 2 and a number like 4. So let's continue this exercise with other numbers. I'm going to skip over 3 real quick, and when I come back to it you'll see why. But let's jump to 5. We're going to circle 5, and then we're going to cross off every multiple of 5. So 5 plus 5 is 10, 10 plus 5 is 15, so we're crossing that off. 15 plus 10 plus 5 is 20, 20 plus 5 is 25. And of course, you see that just like with the 2's, you can kind of ignore the 10's place when you're trying to recognize multiples of 5. All you have to do is look in the 1's place. If it ends in a 5 or a 0, you can just cross it off because you know it's a multiple of 5. Same way that you could recognize even numbers. If it's 2, 4, 6, or 8, you can just cross those off. So 2 and 5 are these indivisible numbers, and so far that's all we have. And I'll just tell you the name. Those are called prime numbers. All of the other numbers that we're crossing out are called composite numbers. I believe this is a skill that comes up in 5th grade, but it is something that I think that students that are way below 5th grade can understand, and it especially if you remind them that this is something that they're going to see in 5th grade, and if they're in 3rd grade, it's a big confidence booster because they're like, oh man, I'm doing stuff that the big kids are doing. So I like to remind them of that. But here's where it really gets interesting, and I think even the older kids can learn something. So we're going to circle 3, and then we're going to cross off every multiple of 3. So 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 3 is 18. 18 plus 3 is 21. And of course it makes sense that some of these numbers are getting crossed off twice, because not only are they multiples of 3, but they could be multiples of 2, like 6 was, or they could be multiples of 5, like 15 was. So it's not like they are only multiples of one number. Sometimes those multiples overlap, and that's a very useful idea when you're doing something like adding fractions with different denominators. Whoops. It's nice to know that 3 and 5 overlap at 15, and if you do an activity like this, maybe that helps build your intuition that that's where they overlap, and that would be their common multiple. So, all right, 21, crossing off 24, crossing off 24 plus 3, which is 27, crossing off 27 plus 3, which is 30, crossing off 30 plus 3, which is 33, 33 plus 3, 36, 36 plus 3, 39, 39 plus 3, 42. This is a good exercise for younger students to build their fluency with adding small sums in their head really quickly. They should be able to count by 3. Helps them recognize multiples of 3. And then, like I say, it builds their fluency with adding small sums. 48 plus 3, 51. 51 plus 3, 54. 54 plus 3, 57. Now, maybe you saw this way before I'm about to say it, but there is a pattern that is going on with the 3's. You can see this diagonal pattern. So you would cross off all of these, which we already have. We would cross off all of these except for 3 because it's the first one. Cross off all of these. Cross off all of these. Of course, we can extend that pattern down through the table pretty comfortably. 63 is a group of 3. 72 is a group of 3. 81 is. 66, 75, 84, 93. The next one would be 60, and if we cross off this one, we can go diagonally here. And 99 or 90 and 99 is the next one. So you see 3's create this diagonal pattern, and that is the reason why this next rule that I'm about to teach you is valid. If you add up the digits of all of the numbers in this diagonal, you will get it to equal 3. 2 plus 1, 1 plus 2, 3. If you add the digits of the numbers in this diagonal, it will equal 6. 5 plus 1, 4 plus 2, 3 plus 3, 2 plus 4, 1 plus 5, and 6. Likewise, all of these will add up to 9. All of these will add up to 12. All of these will add up to 15. And all of these will add up to, well, except for that one. And I guess this number right here doesn't really follow the 15 pattern, but it adds up to 6. So it adds up to 9 or 18. So all of the multiples of 3, the sums of their digits are also multiples of 3. The sums of the digits. So you add the digits, and what do we get? Multiples of 3. So obviously 3 is a prime number, and now that we've got this list over here, not only do we need to know what the prime numbers are, we need to be able to detect their multiples easily. And it's pretty easy to do with 2. It's just, are they even numbers? And if they are, that means they are composite because they are multiples of 2. With 5, are their ones digits 0 or 5? And if so, then they're multiples of 5. And again, the way you detect even numbers, let me be explicit here, is that their ones digit is either 0, 2, 4, 6, or 8. So for both of these numbers, you look at the ones place to identify whether or not it's a multiple of that number. But 3 is completely different, as we see. So I'm going to write it in the, using mathy language here, and then I'll explain it and make sure it makes sense. But sum of digits is a multiple of 3. Again, look at all of the numbers that we crossed off diagonally. What happens if you add the digits of that number? 57. 5 plus 7 is 12. 12 is a group of 3. So that means that 57 is a group of 3. 7 plus 8 is 15. 15 is a group of 3. That means that 78 is a group of 3. So not only, can you just add up by 3 and catch those, but you can just know that these diagonals exist, and what is the reason, or what's the common thing along these diagonals is that their sums are all the same. So what are all of their sums? Groups of 3. So hopefully I've been clear about that. If you need me to clarify it some more, of course you could schedule a lesson, but maybe you could just also practice looking at random numbers on this table and kind of determining for yourself whether or not they're groups of 3, not by counting by 3 until you get to that number, but by adding the digits and seeing if you see a multiple of 3. Okay, so that means that all the numbers we have so far left uncrossed are prime numbers, right? Well, except for one number here, 7. 7 is prime because it has not been crossed off before, but it does not have an easy rule for detecting the multiples like these other numbers do. So I think you just got to know them. Now, you do know a lot of your 7s already because you've learned your times table. I mean, especially if you're doing this activity, usually people have learned how to count by 7, so maybe if you've done it enough times, you've memorized the multiples of 7, but 7, 14, cross it off again, 21, 28, 35. Do you see how all of these numbers have been crossed off already? So we don't really, there isn't a easy rule for detecting multiples of 7. But thankfully, you really don't have to, because if you detect the other multiples, then you can break it down a little bit, and you won't need to catch that it's a 7, because the 7 will be left. Like, think about 21 right here. If you catch the 3, you will find the 7, because 3 times 7 is 21. And that's been the case with all of the numbers so far, right? 35, 42... But then here's the first one that is purely a group of 7 and not a group of 2, 3, or 5 already. And the reason why is because it's 7 times 7. So that's the first 7 that you have to memorize. But if you think about it, you should already be able to look at 49 and see that it's a group of 7 because of division and multiplication facts. So that's not new. You should know that 49 is not prime because of that. Again, let's keep counting. 49 plus 7 is 56. 56 plus 7 is 63. 63 plus 7 is 70. 70 plus 7 is 77. Let's be honest with ourselves. Is anybody going to have a tough time detecting that 77 is a group of 7? I don't think so. It's very easy to see the 11 in it. So don't have to worry about catching 77. 77 plus 7 is 84. 84 plus 7 is 91. I'm gonna put a star on this one real quick. And then 91 plus 7 is 98. So 91 is a group of 7. But it's not really an easy group of 7 to detect. I think that's a very easy number to think that it's prime, because you think to yourself, oh, it's not a group of 2, it's not a group of 3, it's not a group of 5, and for every other number up to 100, that's been good enough, other than 49 and 77. But when you look at 49 and 77, I think it's pretty easy to see that those are not prime, that those are groups of 7. But 91, I don't think anybody counts their multiples up to 91 usually. If they go beyond 10, they usually stop at 12. So there are people out there that know that 84 divided by 7 is 12. I don't think very many people know that 7 times 13 is 91. So 91 is not prime. But once you filter out the multiples of 2, 3, 5, and 7, every other number on this chart is a prime number. So I think this is a nice exercise for people to do, maybe a little repetitively. Why only do it once? You could do it a few times, because it teaches you about numbers, and of course every branch of math is going to involve numbers. So why not make sure you understand the basics? And what's more basic than numbers? And is this something that you really need to be, very knowledgeable about math to follow? I don't think so. This knowledge can teach you a lot about, this lesson can teach you a lot about the basics without requiring that you already know a lot. I think a 3rd grader could follow this lesson, but I think it would be useful to somebody that's way older than that too. So these are the kind of things that I look to help my students with. Low-hanging fruit that helps deepen their knowledge and appreciation of math, but also will increase their fluency for higher level tasks. Getting through what we expect students to get through in their K-12 education is not necessarily that easy. I mean, we expect a lot of these kids, and so I think we want to ensure that their foundations are strong. So anything we can do to, strengthen those joints, I think is very important. And I have a lot of activities that can do that. So if you enjoyed what you saw here, go to bestmathteacherever.com and you can schedule a session with me. I have some practice activities on my website, gotedmath.com. I can show you what to work on Khan Academy and add you to my class, so that way I can track your progress and make sure all of this is making sense. Or if you have some schoolwork or homework, I can help you think through that as well. But yeah, I had fun teaching you this lesson, the Sieve of Eratosthenes. I think it's about 2,000 years old now, maybe more than that, maybe closer to 2,400 years old. I know it's a very old lesson here, so kids back in ancient Greece were crossing off numbers in the dirt just like we're doing here. So it's kind of a timeless lesson, and I hope you enjoyed it, and let me know if you'd like to learn more. See you then.